in Minecraft, there's a couple of limitations that have always bothered me. The big one, obviously, is that you can't add custom blocks to the game. They added custom model data for items, but you're still sort of out of luck on blocks. Another one is entities, and another one that a lot of people don't realize is particles. Right now, if you want to create a particle, you basically have to replace one of the existing particles. And unfortunately, unlike blocks, there's no unused particles to replace, which means that whatever particle you replace will end up replacing something else that's currently in use. So say you wanted a custom particle for every time you hit a zombie, you'd have to replace, say, bubble particles or dust particles. But what if I were to tell you that using the power of Denizen, I managed to create a framework to make custom particles in Minecraft? You would probably say, I already knew that, that's why I'm watching this video, and that's totally valid. But I'm going to walk you through how this framework works, and I'm going to show you how to make a custom particle of your own, and I'm going to show you how incredibly easy it is, and you'll be surprised that no one has ever done this before. So step one, let's get the particle framework installed so we can take a look at what we're working with. Go to the resources section of the Denizen forums, there's a link in the description if you're watching this on YouTube, and download the custom particles zip folder. I have one on my desktop right now, and if you open it up, you will see two folders and a DSC file. So that's core, textures, and the DSC file. What we're going to do is we're going to take the core and particles folder and put these in the plugin script section on your server. So I'm going to open up my script section, which I have right here. That's Denizen scripts, and I have a folder called temp, and I'm just going to drag particles and core right there. And lastly, and then take the textures and put those in the texture section for your Minecraft client. When you finalize all the textures, you're probably going to want this to be a server resource pack, but in the meantime, it's actually easier to have them locally for iteration purposes. So we're going to do that real quick. I'll open up the texture section and I'll just drop those in right there. And once we're all done, we can just start up the server. So I'm going to open up this. Great, so now that we're on the server, let's try running our spawn particle task. So /ex run spawn particle, and you can see it pop up in autocomplete. And if we run it and look down, oh, let's put our resources on, and there we go. That is a particle. You'll notice it kind of looks like the Gmod or Half-Life missing texture particle, and that's intentional. I created it that way. Just this is basically what happens when you run the spawn particle task and your what you have passed is not valid. It will create this missing texture for you. It's not perfect, obviously. You can still pass stuff and it can get malformed. You could just end up with a big old long string of stuff. But as like a sort of a nicer fallback, if you say, for example, just mistype the data script name or something along those lines, you should just get this nice little particle, which shows you that things are still working. You probably just mistyped something somewhere. And you're probably wondering, how is this working? Well, let's just take a quick look inside the scripts folder that the scripts that we downloaded and see what we have. So we have particle.dsc, which is just example particle, and then we have in here under core custom particle. So what we have here is a couple of scripts. We have 1, 2, 3, 4, 5, 6. So that's 5 task scripts and 1 data script. We have update particle, which you don't need to use. Particle position, which is actually procedure. So 4 tasks, 1 procedure. We have remove particle, teleport particle, and spawn particle, which are the 3 we care about. And then a hard-coded particle, our error particle, which is what we're seeing be displayed right now, which is not a good example of what a particle should look like. Technically, they should look like this. This one has a colors tag, which is not necessary. It is actually only being used in this one very particular instance. It's basically just saying if the particle that you're running is an error particle, check for this tag, otherwise don't. So you cannot put colors here. You cannot hard code them into your particle the way that I have done here. I'm just throwing that out there, making it exceptionally clear that this does not work for other particles. How you would normally do it is you run your spawn particle task, you pass in a location, you pass in the name of the script, so for example, error particle or example particle. Then you would pass in the colors that you want, which in this case is a comma separated list of colors. Anything that can go into the pre-pending color tag will work. So for example, a hex code, which is what I have here, a list of hex codes, or for example, red like this would work. Or just red would work. Basically, anytime you have any sort of color that you can put in between these two brackets and get a valid result out, that will work. So for example, if we did this, color red doesn't exist for tag color. There we go. Yeah. So for example, we could pass in red like this, which is an actual color tag. Actual color tag will work, or we could do FF0000, which is the what do you call that, hex code for the color tag, or we could just pass in the word red like that. I think RGB values work too. I don't know. I'm about to check. We're about to see 25500. No, I guess not those. I always use fucking X values, so I don't know. I was just guessing. But basically, anything that goes here and would work, those are all valid for what you're passing to your run script. And then we also have the amount of particles that you want. So if you wanted to spawn, like, say, 15 particles at a time, you could do that. And then an offset. So that's similar to the offset for the actual play effect command in Denizen. And then also not listed here is just a list of players. The players that you want to be able to see the particles. And you don't have to do a list single. You can literally just, when you X run spawn particle like this, A, B, C, D, E, F, and then when you pass in your players, you can just pass in player like that. Whoops, we'll just say player 1 like that, and player 2 like that. I do some trickery on the back end. I don't know if it's like super trickery. It's probably not technically the way that these work, but I've always found list singles and lists to be a little bit finicky. So I just find it easier that, hey, you can just pass in a list. It'll take any amount of arguments. Don't worry about it. And that's all you need to do to run a particle. Once a particle has been spawned, you'll notice this particle is just sticking around. Fake spawn particles normally despawn or disappear or whatever after a certain amount of time. But in this case, our duration is 1 year. So this particle's not going anywhere. It's important to make sure that the particles, when they've been determined out of this task, you save that result and then remove the particle down the line, or it will just stay there forever. Fake spawn particles will disappear when the server restarts as well, so that's good to note. If for whatever reason you didn't save those values, I believe that's one way that you can get rid of them. I don't believe just trying to locate the particles, because they don't technically exist on the server side, so that wouldn't really work. So it's important to keep track of them, is basically what I'm saying. And then, obviously, when you keep track of the particles, you can manipulate them and move them around using the teleport particles command, which is just you pass in a particle and then the location. And the reason we're doing this, instead of just you running, say, the teleport command, is because, one, we slightly adjust the particle, and that's due to how when a particle, the current particle that's being spawned is a marker armor stand, which means that the name tag is very low to the ground, but it's not perfectly where the location is. It's off by about 0.3. Did I do some math to figure out what the exact offset was? No, I actually just eyeballed it, but it seemed to be pretty close to when I was doing it myself. So we handle that offset for you, and then also due to the fact that these particles don't actually exist on the server, we do need to keep track of the position of the particles, so that later we can get the position from the server flag. We can grab those positions and then manipulate them however we want. Obviously, we don't need to keep track of anything else for the particle, but the position is sort of important to be able to do anything fancy with it, like moving it around. Now you might be wondering, okay, great, so I understand that you have an armor stand and it's somehow creating the particle, but how does that actually make the particle? Like, did you replace the armor stand? No, it's actually much easier than that. The secret sauce is all right here in the custom name. So you'll notice that it's basically and charactered this thing, and then we're getting the first color from the color list that we passed, and then we're doing another and character. We're getting the first frame, and then we're doing another special character. So you might be wondering, okay, how does that work? Well, if we were to take this special character just like this and narrate it like this, hi, whoops, we'll put that there, and then we'll say, hi, my name is, just like that, and press enter, and you'll notice the text has been offset to the left, right? We narrated, hi, my name is, and it even shows up here as well. The text has been offset so that this text is now sitting over top the word narrating, right? This character F801 has been designated specifically inside the font section of our textures file that we dropped earlier, and we'll take a look at that in a second, to basically be a negative offset to any text before it. And then if we were to put another one of those on the other side, I guess it doesn't. Oh, interesting. Well, it doesn't work. It doesn't work with regular text. It does work with this sort of text. So I'll show you something. So we have here our armor stand with the name of Bob, and you'll notice something. Most nameplates, or all nameplates rather, have this black outline or black bar underneath them, and that's to help with readability. And you might notice that this one over here doesn't seem to have that. You might think it's actually just hidden behind the square, but it's not. It's fully gone. And you're wondering, well, okay, so how is that possible? What have you done to this text? What have you done to the nameplate to make it do that? And if we were to basically change the custom name of this to use that character just like before, we know it'll offset, which we saw in our chat window, but what you didn't see is that the bar disappears. This is something that happens on nameplate specifically. Doesn't really happen in chat. Something that also didn't seem to work in chat, but does work for nameplates, is that if we were to then put that same character on the other side, it readjusts the name back to the location it started in, but now the name, that black bar nameplate behind it, is gone. So we can create these custom nameplates effectively without that black bar. Now, how does that work? Well, if we take a look at that custom resource that we loaded in earlier, and we just open up our packs and take a look at these textures, we can see that we have, oh, well, I'm not going to scroll every time. We have two files. We have font and textures, and if we open up the fonts file, we have a default.json, and if we open that up, we can see some of the magic sauce here. We have a bunch of objects that include, hey, look at those. Doesn't that look kind of similar to the character we put in earlier? These are basically the frames of our particles. So when we're creating a particle, this is how we create a frame. And if we were to scroll over here, we can see the different frames for the error particle. So frame 4, frame 3, frame 2, frame 1. And you'll notice they have an ascent of 16 and a height of 16, which is designates the size of the particle. And then F804, 3, 2, and 1 F802, 3, 4, and 5 are our error particles. And if we scroll all the way to the bottom, we can see another one that has a negative ascent and negative height, and hey, F801 is the character that we were using that negatively offset thing. So what space is a 1 pixel image that has an alpha of just 1, so it is effectively invisible, but not technically invisible. And it has a negative offset, which means that when we put it into our text, it gets pushed to the left, or gets pushed to the left technically. And then when we put it on the other end, it basically gets pulled back to the right. And Minecraft doesn't have that black bar because it thinks that the length of the text is negative, 46 or whatever. And so it's not drawing that black bar behind the text like you think it would. And so that's basically how that works. We basically just put this in front of a character, which is one of these characters, and then we just update this middle character, right? We have two of these, and then one of these sandwiched in between. We just update this one over and over to get the different frames of our animation, and this makes sure that the particle doesn't have a black bar behind it. And that's basically all you really need to do. That's like the most complicated part of getting this particle stuff working. And if we were to go into the textures again and back out here, and we were to go into the textures folder, we have font, and then we have base, and then we have error example in space, which we saw listed in our default JSON. We see font base example, and down here font base error. And if we were to open up these folders, we can see the frames of our particle. And if we opened up error, doesn't that look kind of like, oh, that can't zoom in, I guess, but doesn't that kind of look like the frames of the error particle that we have displayed in our in-game right now? So that's all you really need to do to get that working. So you're probably thinking, okay, that's pretty fucking cool. How do I actually, what are the exact steps I need to do to make myself a particle just like this? Well, it's super easy. All we have to do is go back into that textures folder, and we're gonna back out to base, and we're going to create a folder, and we'll call this my particle. And you can call it whatever you want. And this is where we're gonna store the frames of our particle. Now, I'm really lazy, so I'm actually going to dive into here and grab the frames. Whoops, that's the error. I'm gonna dive in here, grab the frames of my example particle that I have done before, and put them right in here. We got frame 1, 2, and 3. And if we were to edit frame 2, you'll notice that frame 2 is actually the letter, it's just the word hi. And it's all white. Anything that's white is affected by coloring, and anything that is, not white will not be affected by coloring. So it's important that however you end up making your particle, make your particle in grayscale so that it can be affected by coloring after the fact. If you don't want it affected, you can just draw the color in just like this, but be aware that this color will be affected by the colors that you pass to the particle after the fact. So it's best to just do it in white. So we have the word hi here. Let's clean this up a bit. Let's just make this a little bit prettier. Hi. Oops. Let's clean this up here. We can just go hi, like that. Sure. That's not annoying at all. let's just here, fix it. We'll fix it. It's okay. We'll just do a square like that. There we go. Hi. Much better. Now we've got a nice big blocky hi as our second frame, so we'll save that as a PNG. You'll notice that it is a square image, 16 by 16. You can make it bigger or smaller if you need to. And then what we would do is we go back into that default JSON, and we're just going to copy one of these objects. So we copy this one and put it right here. It is a bitmap, so we don't need to change that. This basically means we're rendering an image, and our folder is located at font, and then it's called my particle, just like that. And I will say, I have them saved as numbers as well. Technically, you can have them saved as whatever you'd like. I like to use numbers because it's easy to keep track of which frame is the first frame, second frame, third frame. So frame 1 will be on character 9. Frame 2 will be on character 10. And frame 3 will be on 11, just like that. There we go. So that's the 3 frames of our custom particle. If you want the particle to be rendered bigger in game, you would change the ascent and height of the particle so we can have it be big or small here. Keep in mind that these two numbers should match. Really, if you're changing like a whole set, all of these should match. And so if you wanted to have like a big version, a medium version, and a small version, you'd have to have 3 separate copies. So you'd have, this is say the medium copy, and then we'll copy all this in, and we could change this to 32 for all of these. So now we have a medium copy and a big copy. And keep in mind that when you do that, you also then have to make these unique characters as well. So that's 13, 14, and 15. No, sorry, 12, 13, and 14. So 12, 13, and 14 are our big versions of the particle. 9, 10, and 11 are the medium-sized version. I could make a small. You get the idea. And it's important to make sure that any particle you're using in-game isn't already an actual character. So an easy way to do that is to just type out and character like this and paste in the Unicode that you want to use, and just check to see if it shows you anything. So if it's a white square like this, that means it's not being used full go crazy, you know, have fun with it. If we were to do something like, I'm gonna guess here, G 3 4 3 1. Oh, that's not anything. A B C D E F G. Oops, sorry, I meant to go the other way. D431 is a Chinese character, so we don't want to overwrite that character, right? So just make sure that nothing gets rendered. If it's just a blank square, you're free to go. So we have 2 sets here, basically, our medium and our big, and then we can go into our folder, and we can just create our data script. So we're going to create our medium particle like that, which was 9, 10, and 11. And this one will say updates really fast. And then oh, I spelled medium wrong. Medium. And then we can have a big particle like this. Big. And this one updates really slow. And let's say 12. Let's say we'll do a couple frames like this. So 12, 12, 12. 13, oh, that's gonna take forever to go through. So we'll make it slower, but 12, 12, 12, 13, 13, 14. So it'll do the first frame 3 times, and then the second frame 2 times, and then the last frame 1 time, and they'll cycle back around. And it'll wait 5 ticks in between each one. So that's what this means. This wait is how many ticks we're waiting in between each frame. And then this is just a list of the frames that we want to display. Now keep in mind that the frames and the colors don't have to match. You can have 30 colors and 3 frames. What that means is that you'll do 3 frames 10 times, and then the colors will be done, right? And then all of it will start over. But it just means you'll do 9, 10, 11, 9, 10, 11, 9, 10, 11 while you're going through your colors. Or you could have 2 colors, right? Where it would be, maybe you had red, blue. It would be red, blue, red, blue, red, blue. So they can be different sizes. And when you do something like this, right, if you say doubled all of your things, you can have the colors update faster than the frames update, right? Because they are updating, but because you said you wanted more to display, it would look like the colors are moving faster than the actual image was, right? So you can sort of mix and match, or you could do it the other way. You could have yeah, anyways, you get the idea. You can have a list of colors where like the colors are duplicated, but the frames aren't, so it looks like the colors are slower than that. Again, you get it. So once you're done with that, we'll just hop back in game, and we're basically done. All you have to do is reload your textures, which I thought was F3T, but it's not. Is it F3G? It's not. Is it F3F? Oh my gosh, what is it? There's an F3 button to reload textures. I did press F3T, and it didn't work. There we go. Reload my texture pack, because we created those new textures, so you have to reload the texture pack whenever you do that. And then all we have to do is spawn our new texture in. So we're going to do X run, spawn my particle in. Sorry. X spawn, and I'm going to do player.iLocation.forward 2, so it'll be spawned in front of us, and the particle name, which we'll do medium, particle, just like that. Oop, we did something wrong. What did we do wrong? MEDIUM. Oh, you know what we did wrong? We never reloaded our script. That's what we gotta do. Ooh, no. Oh no, that's not great. Sorry, we all saw a bug there that wasn't supposed to happen, but no worries, we got it fixed. And as you can see, that is our texture updating insanely fast. Remember, we have that wait tick of only 1 in between, so our medium particle, very, very fast. And if we were to spawn in our big particle, which has a slower update rate, right? You can see it does the first frame 3 times, and then the second frame, which is our high, 2 times, and then the last frame, just 1. So bup, 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 like that. So as you can see, you can sort of manipulate that how you like. And this one is clearly much bigger than this one over here. And then lastly, well, not really lastly, but those are the only 2 things you need to pass in, but you can pass in other things. So let's say I wanted FF0000, which is red, and then, ooh, let's say, I'm just gonna try to do this off of my brain. So it's 16. Does 11 work, I wonder? Oh god, we're gonna find out. 00, and then one more, which FF2200. Oh boy, I don't think I can do numbers like that. Is that a thing? Oh boy, it's like 16 and then it wraps around. Fuck. I don't. Oh, it's like 9. Oh, okay, I can do 22. That works. And then I'll just do FF1100. So those are colors. So there we go. It's not noticeable. That's what I get for typing colors out manually. What if I did 55 and then AA and then 55? Would that be noticeable? Ooh, there we go. Much better. Now you can tell the colors are changing. And you can see the colors are changing independent of when the texture actually changes. And then after that was amount, so we could spawn in more, or we could spawn them in on offsets, or however we wanted to do it. And it's important, I have not done it here, but it's important to keep track of these particles, save them, so that we can manipulate them, so that you can use the teleport task to move them around, and so that you can remove them afterwards. I think I mentioned that earlier. So I'm going to clean all this mess up, and I'm gonna write out a script real quick that can sort of show you like what a particle might, what you might actually do with a particle, and how you might actually be able to utilize this script. So I'm gonna do that and I'll get right back to you. All right, so I'm back and I have my task for you, and if we'd like, we can just take a quick look at it before we run it. So it's not super complicated. I just hand grabbed a bunch of colors. I would maybe do this more programmatically if I were actually, doing this for like maybe a server or something like that. But I just went online and fucking found a palette and did it the hard way. And I have a spawning task that creates 15 particles. And the reason I'm using repeat instead of amount is so that I can have them sort of spawn at separate times. And that's because when you do amount, they will all spawn at exactly the same time, which means that particle animations will also go at the same time, which I didn't want. So this is just sort of a cheap way around that. And I basically spawn the particles directly in front of me. I have 3 scripts now, 3 particle scripts, which is basically a small, a big, and or like more like a small, medium, and slightly mediumer. Or actually, no, scratch that. It's medium, small, and smaller is what it is. And then I am just getting that list of colors. I'm spawning 1 particle with no offset. And then I am saving it. And technically, if I wanted to be real, good about it, I would pass myself in. But since I'm the only person here, it will implicitly just grab me. Not a big deal. If there were other people, obviously I'd want to include them. And then I'm going to run my repeating task, which is the task that is updating them with that particle that I've saved. Wait a couple ticks and then do it again. And then in my repeating task, I do this 5 times and then I remove the particles. But basically, I get the location that they started at. They are currently at. So this is me using that particle position procedure task. This is how that works. I'm getting the position they are starting at, and then I'm getting the position I want them to move to, which is in a cuboid I created. I called it Fireflies. I'm finding blocks of air. I'm going to grab a random block of air, and then I'm going to get the center of that block. And then I'm going to get speed, which is just how fast I wanted stuff to update. I just kind of played with it until it felt right. Again, none of this is like particularly clever. I was just trying numbers in a lot of cases. And then I have a counter right here called I. I use percentage basically, I create a definition called percentage, and I use my ease task, which is part of the utilities, like I mentioned before. A lot of the particles framework uses my many things library, so that's kind of already built in. So this is definitely something you could do. You can't run the framework without it, so you might as well take advantage of all the cool things I have in there. But I have the easing function, I have the circ out easing function, and basically this returns value between 0 and 1 up until it's finished, and then it returns false. So basically we're making sure that it's still a number, and if it is a number, then we do some math. If it's not a number, we stop. And the math that we're doing real quick looks kind of complicated, but it's not. We're just basically doing the same thing 3 times on X, Y, and Z, which is we are taking that percentage and we are lerping, which is a linear interpolation from the starting position to the ending position. So from the starting X to the ending X, from the starting Y to the ending Y, from the starting Z to the ending Z. We're basically just doing the same thing 3 times. And then this moves us, so this gets all the positions for basically from where we start to where we end. And once we've done that, then we loop through the positions and we teleport our particle there one tick at a time. And then once we finish doing that, we get the new position, the ending position where we stopped at. And then for about a couple seconds, we just sort of bob about, which uses libSineWave, which is basically just a helper procedure I have on the .sine function, which allows you to pass in like amplitude, frequency, stuff like that. It's a little bit easier to keep track of what it's doing this way, I find. And so we're just doing that we're just doing the same thing 3 times, which in this case is a sine wave on the X, the Y, and the Z. We're using the relative function. And we have all the values slightly different. So this is 04 for X, 05 for Y, 04 for Z, but then this is 0.5, 0.5, 0.5, and then and this is amplitude, so how far it's moving, and then this is frequency, so this is the slowest one, and then the fastest one is Y, and the second is Z. So hope they kind of like bob about in kind of a chaotic pattern, but not really. It's just a bunch of different circles and they don't line up. And then we just move them to that new position over and over and over. And then once we've done that, we do it 5 times, and then once we do that, we remove all the particles. And it just uses that same particle that we made before. I just made more entries of it and just renamed them from example particles. So if we run my spawning task, which is what I called it, you can see them spawn in. And then boom, we have a bunch of floating circles that have the word hi on them. It's not anything crazy. It'd be super cool if they were also like emissive or something like that. But now I'm really like fighting up against like what Minecraft can and can't do. Yeah, that's a bunch of fairy Navi looking motherfuckers floating about. We'll spawn a whole bunch of them in. That's 45 particles right here with seemingly no impact on the server, right? They seem to be fine. I don't know how hard I can push this, but we're updating the animations, we're updating the colors, we're updating the positions, we're doing a hell of a ton of math, and no problem at all. Server takes it, easy peasy. I gotta say, this framework's fucking great. I'm loving it. I think this is super fun. But yeah, so that's basically the end of how this works. So if you guys are interested, if you use Denizen, go check it out, download it, try it, have fun with it, do cool stuff. I'm not much of an artist, as you can see by my circles that occasionally turn into the word hi. There's nothing impressive here. But, you know, somebody who's maybe a little bit more artistically inclined could maybe make some really cool particles and then just use a bunch of the math that I've already created to make them move the way that you want. What is that? Was that 4 times? It's like 50, 60 particles? I don't know how many times I can do this. It doesn't seem to be struggling. It's getting busy in here. Woo! Hey, there we go. There we go. There they go. Floating about, doing their thing. It makes me giddy, I'm not gonna lie. Anyways, be safe, have fun, go do some particle stuff.